Last spring, a team from San Francisco State University and the United States Geological Survey conducted research at Ocean Beach in order to gain a greater understanding of the currents and wave patterns on San Francisco's western edge. The area south of Sloat Boulevard is prone to erosion, and parts of the Great Highway were closed following strong storms last winter.
There is obviously strong, large erosional problems on the south end of the beach. I mean, in the recent storms over the winter, that became very clear when the Great Highway was eroding, had to be closed off, and other infrastructure was in danger because of that. So that is certainly an issue, and that's also one of the driving motivations for this research directly. A big shoal offshore of here causes the waves to refract and focus on the center of the beach, which causes the waves to be much bigger there than elsewhere. At the same time, there's strong longshore currents or strong nearshore currents associated with the Golden Gate, the tidal currents flushing through the Golden Gate, which is very unique for this place that there's such strong tidal currents in the nearshore. So the combination of those two makes it a very complex area in terms of its hydrodynamics, and as a consequence, very hard to model, predict what's going to happen to the beach, and then trying to understand what's going on. That's really what we're trying to do here.
So we have sensors that are out like offshore of the surf zone in about 10 meters of water, or about 30 some feet of water. That's basically to get our waves like before they break, like the waves like information before they're breaking in the surf zone. And then the ones that are in the very near shore right here in the swash zone are mounted on stainless steel 1.5-inch poles that have had a fire hose attached to the top, and then they were jetted into the sand. So basically we pumped water down the poles and liquefied the sand and kind of decapitates a hole and just slides down in, and there's about 7 feet of the pole underneath the sand with a pressure sensor near the bottom of the pole. So the pressure sensor is buried in the sand.
Alright, so what we try to measure is a combination of pressure fluctuations and velocity of the water. So what that does, basically, what you do together, you try to measure all the different forces acting on the water, and part of that is pressure driven, so differences in pressure will cause pressure forces on the water. Differences in velocity will give you a measure of how much momentum is in the water and how that is transferred from A to B. And together we're basically trying to see if we can put the whole picture together on what are the forces that are acting on the water and how then does the water move as a consequence of that, and does our model, our idea of how that should be working, does it apply here, or are we missing steps? Indirectly, of course, it becomes a question of like, how does all of this work? I mean, that's how we, as a scientist, how I'm interested in it. I mean, of course, I'd like to understand that, I'd like to be able to model that, I'd like to be able to predict that and help mitigate it. But at the same time, I think to really do something with that, you really have to understand the processes and the system as a whole, and not just maybe that one location where something is going on.